Welcome to today's episode. If you're new here, this channel is a quiet place for calm science and slow human stories, designed to be listened to gently, often at the end of the day. And if you genuinely like what I do here, you're always welcome to like the video or subscribe. It helps this work continue slowly and steadily. Tonight, we're going to talk about something you did today without thinking about it. You stood up, you walked, you shifted your weight from one foot to the other. It felt ordinary, but it wasn't always possible. For most of the history of life, standing upright was not how bodies moved through the world. It was risky, unstable, energy expensive. 4 limbs on the ground were safer, lower, more predictable. Early ancestors did not look at the world from above their hips. They experienced it close to the ground, through branches, through foliage, through constant contact with surfaces. Their spines were not designed to balance a vertical body. Their hips were narrow. Their feet grasped rather than supported. Walking upright was not an improvement at first. It was a compromise. To understand how humans learned to walk on 2 legs, we have to forget how natural it feels now. We have to imagine a body that was not built for it, a body that climbed more than it walked, that leaned forward, that relied on arms for stability. In that world, standing up straight meant exposure, more surface area to the sun, less speed to escape predators, more pressure on the spine. So why did it happen? Not suddenly, not by decision, but slowly across thousands of generations. The earliest steps toward upright walking did not look like modern walking at all. They were pauses, moments of rising up to look over tall grass, short distances crossed while standing, balancing briefly on 2 legs while carrying something, food, tools, infants. These moments mattered. Standing freed the hands. Hands that were once used mainly for movement became available for holding, shaping, and manipulating. This change alone reshaped survival. An upright posture also changed what the eyes could see. The horizon became wider. Distant movement became visible. Threats could be detected earlier. These advantages were subtle but consistent. They did not make life easier. They made it possible in new ways. Over time, bodies that could tolerate brief upright movement survived slightly better in certain environments. Not everywhere, but in open landscapes, where trees were sparse and distances mattered, upright posture offered something new. Efficiency. Walking on 2 legs uses less energy over long distances than moving on 4. It is slower, but it lasts longer. This endurance mattered. Early humans were not the fastest animals. They were not the strongest, but they could keep moving. Standing upright also changed breathing. The chest expanded differently. Rhythms of movement and breath aligned. This coordination allowed sustained activity without exhaustion. But none of this came without cost. The spine began to curve in new ways. Hips widened. Knees locked differently. Feet lost their grasping ability and became rigid platforms. Pain entered the story. Back strain, joint stress, balance challenges. Even today, these costs remain. Human bodies still struggle with the consequences of standing upright. But evolution does not erase trade-offs. It accumulates them. In the next part, we'll look at how early upright walking actually looked: slow, awkward, and very different from the walking you know today. For now, it's enough to remember this. Walking upright was not a leap forward. It was a long negotiation between gravity, energy, and survival. And your body is still part of that negotiation every time you stand. When we imagine the beginning of upright movement, It's tempting to picture confident strides. That image is misleading. The earliest forms of upright posture did not resemble human walking. They were unstable, brief, often supported by the arms. Early ancestors did not abandon trees all at once. They moved between worlds. They climbed when needed. They walked when possible. In trees, their bodies still made sense. Long arms, flexible shoulders, grasping feet. On the ground, those same features became limitations. Standing upright was something they did intermittently, a way to reach, to carry, to scan the environment. These early upright movements were slow. Balance was uncertain. The center of gravity was high and forward. Spines were not yet curved to support vertical load. Hips were narrow. Knees were not aligned for efficient weight transfer. Falling was a real risk, so movement was cautious. Short distances, frequent pauses, hands often ready to assist. This mixed style of movement is still visible in some living primates today. They can stand and walk briefly, but not comfortably or efficiently. Their bodies reflect an earlier stage. The shift toward habitual upright walking did not require perfection. It required tolerance. Small anatomical changes allowed slightly longer periods of standing, slightly more efficient steps. These small advantages accumulated slowly. One important change occurred in the pelvis. As upright movement became more common, hips widened and rotated. This change stabilized the trunk. It allowed muscles to support the body during single-leg stance. Without this adaptation, walking upright would collapse under imbalance. The femur also changed. It angled inward toward the knee. This brought the feet closer to the body's center of mass. Each step became more stable. These changes are subtle when viewed individually. Together, they transformed movement. The spine responded as well. Curves developed gradually, not as a single arc, but as stacked adjustments. These curves absorbed shock. They allowed the head to balance over the pelvis. This alignment reduced muscular effort. Walking became less tiring. Feet changed last. Early feet still grasped. Toes were long and flexible. Over time, the big toe aligned with the others. The arch formed. The foot became a lever rather than a hand. This improved push-off. It also reduced climbing ability. Every improvement for walking reduced ability elsewhere. Evolution did not remove climbing skills lightly. It traded them carefully. Environment influenced these trades. As climates changed and forests opened, ground travel became more important. Food sources spread out. Distance mattered. Bodies that could move efficiently between resources survived more reliably. Upright walking was not chosen. It was reinforced. In the next part, we'll explore how walking upright changed how humans used energy, and why endurance, not speed, became our defining strength. For now, remember this. The first upright steps were tentative. They were experiments, and they succeeded not because they were perfect, but because they lasted. Once upright walking became more common, something important began to change. Human ancestors were no longer optimizing for short bursts of movement. They were optimizing for distance. Four-legged animals are often faster over short spans. They accelerate quickly. They change direction easily, but they pay a higher energy cost over long distances. Walking on two legs is slower, but it is economical. Each step transfers weight efficiently from one leg to the other. The body behaves like a pendulum, conserving momentum. This matters more than it sounds. Energy is survival. In environments where food was scattered, efficiency mattered more than speed. Early humans did not need to outrun predators. They needed to outlast conditions. Walking upright allowed long journeys without exhaustion. It allowed travel during cooler parts of the day. It allowed carrying food back to others. Carrying is an often overlooked advantage. When the hands are free, movement changes purpose. Food can be transported rather than consumed immediately. Tools can be carried rather than left behind. Infants can be held rather than left vulnerable. These behaviors reshaped social structure. Sharing became practical. Group survival improved. Endurance also changed hunting strategies. Early humans were not fast enough to chase animals in short sprints, but they could follow. They could maintain a steady pace. Over time, heat and fatigue slowed prey. Upright posture aided this. Standing tall exposes more surface area to air. Sweat evaporates efficiently. Heat dissipates. Many animals rely on panting, which limits sustained running. Humans rely on sweating, which supports endurance. This ability is tied to upright posture and body shape. The head also benefited. Balancing the head over the spine reduced muscular strain. Vision stabilized. The eyes moved smoothly through space. This improved tracking of distant movement. Attention could remain outward. Breathing changed as well. With the chest oriented vertically, breathing became less constrained by movement. Steps and breaths could synchronize. This reduced fatigue. Walking and breathing became rhythmically linked. This rhythm is still present. You feel it when walking steadily for long periods. The body settles into a pattern. Effort decreases. Thoughts drift. The nervous system recognizes endurance as a safe state. This is why long walks often feel calming. The body was shaped for them, but endurance required patience. Speed was sacrificed. Reflexes adapted to prediction rather than reaction. Early humans learned to plan routes, to anticipate terrain, to read subtle cues. Walking upright was not just a physical change, it was a cognitive one. The body and brain adapted together. In the next part, we'll look at how upright walking reshaped the spine and why back pain is part of our evolutionary story. For now, remember this. You are not built to move fast. You are built to keep moving. When the body turned upright, the spine became a column. Before this shift, the spine functioned more like a bridge. It distributed weight across 4 limbs. Stress was shared. Standing upright changed that completely. Suddenly, the spine had to carry the full weight of the head, torso, and arms, all aligned vertically, all responding to gravity every moment. This required a new solution. A straight column would not survive long under constant load. Shock would travel directly upward. Balance would be fragile. So the spine adapted gradually. Curves formed, not decorative curves, functional ones. A gentle curve in the neck balanced the head. A deeper curve in the lower back absorbed force. Together, they acted like springs. These curves allowed the spine to flex slightly with each step. Impact softened. Energy was stored and released. Walking became smoother. But these adaptations came with vulnerability. Curves introduce stress points. Certain regions bear more load than others. Discs compress. Muscles compensate. This is why the lower back is so sensitive. It carries the most responsibility. Evolution accepted this risk because the benefits outweighed the cost. Most early humans did not live long enough for chronic spinal degeneration to matter. Survival and reproduction happened earlier. Pain later in life did not strongly affect evolutionary success. That does not make pain insignificant. It explains its persistence. The spine also influenced posture. Standing upright required constant microadjustments. Muscles along the back worked continuously, not forcefully, but persistently. This low-level activity is tiring over time. It is also why posture feels easier when supported. Sitting, leaning, lying down. These positions reduce spinal demand. The nervous system responds with relief. This response is ancient. The spine also changed how the head moved. Balance over the pelvis meant the head no longer needed to be held forward. Neck muscles adjusted. Vision stabilized further. The eyes moved through space with less disruption. This improved awareness, but again, trade-offs remained. Neck strain became possible, especially when head position drifted forward. Modern life exaggerates this. Screens pull attention downward. The head leans. Load increases. The spine responds as it always has, with effort. Understanding this reframes discomfort. The spine is not failing. It is compensating. Upright walking required constant negotiation between structure and function. The spine became a flexible compromise, strong enough to support, flexible enough to move. Never perfect. In the next part, we'll explore how hips and legs adapted to make upright walking stable, and why single-leg balance became central to how humans move. For now, the spine continues its quiet work. Walking upright is not a continuous act of standing. It is a repeated act of falling and catching yourself. With every step, the body shifts its weight onto a single leg. For a brief moment, that one leg carries everything. This is one of the most unstable positions a body can be in. Early four-legged movement avoided this problem. Weight was shared. Balance was wide. Upright walking removed that safety. So the body had to adapt. The hips changed first. They became broader and more bowl-shaped. This widened base allowed muscles to stabilize the pelvis when one leg lifted. Without this change, the torso would tilt dramatically with every step. You can see this instability in animals that try to walk upright briefly. Their hips drop side to side. Balance looks effortful. Human hips learned to hold the body level. Muscles along the side of the hip began working constantly, not to move, but to prevent collapse. This quiet stabilization is one of the hidden costs of walking. It happens every step, unnoticed. The legs also lengthened. Longer legs increased stride length. Fewer steps were needed to cover distance. This improved efficiency. Knees adapted as well. They began to lock during stance, reducing muscular effort. This allowed standing without constant strain, but locked joints are vulnerable. Knee pain became possible. Again, evolution accepted the trade-off. The foot completed the transformation. It stopped behaving like a grasping tool and became a rigid platform. An arch formed. This arch stored energy when the foot landed and released it during push-off. Walking became spring-like. Effort decreased, but flexibility was lost. Climbing ability diminished. Feet became specialized for forward movement, not grasping. Balance shifted upward. Coordination became more important. Walking upright demanded constant sensory feedback from joints, from muscles, from the inner ear. The nervous system integrated these signals to maintain stability. This integration is so automatic that we rarely notice it until something interferes. Fatigue, uneven ground, distraction. Then balance becomes conscious again. The challenge of single-leg balance also influenced pace. Humans walk at a speed that balances efficiency and and stability. Too fast and control decreases. Too slow and energy efficiency drops. The body finds a middle rhythm. This rhythm feels natural. It is learned early in life. Children wobble as they practice it. They fall, they adjust, they repeat. That learning mirrors evolutionary history. Balance was not inherited fully formed. It was practiced. Over generations, bodies that practiced better survived more reliably. Walking upright became stable enough to depend on, but never effortless. In the next part, we'll look at how upright walking reshaped the human foot and why your feet still carry the marks of this long transition. For now, remember this. Every step you take is an act of balance, quietly solved again and again. Before humans walked upright, feet were not meant to bear full weight alone. They were hands. They grasped branches. They adjusted to uneven surfaces. They wrapped around supports. Standing on a flat surface for long periods was not their purpose. Upright walking changed that purpose completely. Once the body relied on two legs, the foot became the foundation. It had to accept weight, absorb impact, and propel the body forward. This required rigidity. Flexibility was no longer an advantage. The most visible change was the alignment of the big toe. In grasping feet, the big toe points outward. It opposes the others. In walking feet, it aligns forward. This alignment allows efficient push-off. Force travels straight through the foot rather than spreading sideways. This change alone transformed walking efficiency. The toes shortened. Long toes bend and waste energy during push-off. Shorter toes reduced strain. They also reduced the risk of injury during repetitive loading. An arch formed in the foot, not a decorative curve, a functional spring. When the foot strikes the ground, the arch compresses slightly. Energy is stored. As the foot lifts, that energy is released. This reduces muscular effort. It also smooths movement, but arches introduced new vulnerabilities. They rely on ligaments and tendons for support. These tissues can fatigue. Pain becomes possible. Flat feet and high arches reflect variation in this system. Neither is ideal or flawed. They represent different compromises. Upright walking also reduced foot sensitivity. Thickened skin formed. Protection increased, but sensory feedback decreased. The nervous system compensated by relying more on joint position and balance cues. Barefoot walking still reveals how much information feet can provide. Texture, temperature, subtle slope. Modern surfaces dull this input. The foot adapts as it always has. It responds to use. Standing still for long periods challenges it. Walking allows it to function as designed. Movement distributes load. The foot also shaped posture. Because it is rigid, the rest of the body must absorb variation. Ankles, knees, hips, and spine share the task. Walking becomes a coordinated chain. This chain requires timing. If one link stiffens, others compensate. This is why discomfort travels. Foot issues affect knees. Knee issues affect hips. Hips affect the spine. This interconnectedness is not modern. It is inherent. Upright walking tied the entire body together mechanically. The foot became the interface between the body and the ground. Every step sends information upward. Impact, direction, stability. The nervous system interprets this constantly, usually without awareness, until something changes. Pain, fatigue, imbalance. Then the foot reminds you of its role. In the next part, we'll explore how upright walking changed how humans carry weight. and why the ability to carry things reshaped society. For now, the feet continue their quiet work, step after step. Once humans could walk upright with reasonable stability, something new became possible. They could carry things while moving. This may sound simple, but it reshaped survival more than almost any other change. When movement requires all four limbs, carrying is limited. Objects must be dragged. Food must be eaten where it's found. Infants must cling on their own. Upright walking freed the hands. This freedom altered priorities. Food could be transported. Tools could be kept. Resources could be shared. This changed how groups functioned. Instead of each individual surviving moment to moment, effort could be pooled. One person could gather. Another could watch. Another could care for the young. Carrying allowed planning. It allowed delayed reward. Food could be brought back rather than consumed immediately. This supported social bonds. Sharing became practical. Over time, this practicality became expectation. Upright walking also changed how infants were cared for. Human babies are born relatively helpless. Their brains are large. Their development continues outside the womb. Carrying infants required balance and endurance. Arms adapted to hold weight for long periods. Posture adjusted. The nervous system learned to coordinate movement while holding another body. This constant contact influenced social development. Touch became central. Bonding became physical. Walking upright supported this long-term caregiving. It also shaped tool use. Tools could be transported to where they were needed, not just used once and discarded. This encouraged refinement. Tools became more complex. Hands evolved precision, but that precision relied on upright posture. Balance through the legs allowed fine motor control in the hands. The whole body participated. Even the rhythm of walking mattered. Walking set a pace, a predictable cadence. This cadence influenced breathing and attention. It made long-distance carrying sustainable. You can feel this today. Carrying something while walking often feels easier than carrying it while standing still. Movement distributes load. The body prefers motion. Upright walking also influenced communication. When hands are free, gestures become possible. Meaning can be conveyed without sound. Direction, warning, instruction. This visual communication likely developed alongside upright posture. Walking together created shared orientation. Eyes faced forward, attention aligned. Groups could move as one. Carrying also changed risk. Holding objects slows escape. Balance is compromised. This required greater awareness. Early humans became more attentive to surroundings. Vision and movement became tightly linked. The body learned to predict terrain while burdened. This prediction shaped cognition. Walking upright while carrying demanded foresight. The environment was no longer just navigated. It was anticipated. In the next part, we'll explore how upright walking changed how humans rested, sat, and used stillness, and why standing forever was never the goal. For now, remember this. Walking upright didn't just move the body, it carried the future with it. Upright walking did not mean upright living. Even as humans became skilled at moving on two legs, stillness remained important. The body was not designed to stand endlessly. It was designed to alternate. Movement, pause, rest. Early humans walked to reach places, not to remain upright once they arrived. They squatted. They sat on the ground. They leaned against surfaces. These positions reduced load on the spine and legs. They allowed muscles to release. The nervous system recognized these postures as safe. Sitting on the ground kept the center of gravity low. Balance demands decreased. Energy use dropped. Squatting, in particular, became a common resting posture. It allowed rest without fully disengaging. Muscles remained active, but not strained. This posture supported digestion. It kept joints mobile. Modern bodies still retain this capability, even if it feels unfamiliar. Upright walking also influenced how rest was structured. After long movement, stillness was necessary. The body required time to recover from impact and load. Feet needed relief. Hips needed release. The spine needed support. Lying down provided this. Horizontal posture removed gravity's vertical demand. The spine could decompress. Breathing changed. The nervous system shifted. Sleep patterns evolved alongside upright movement. Long days of walking increased the value of deep rest. Energy conservation became essential. This is one reason why sleep occupies such a large portion of human life. Walking upright expanded the waking world. Sleep protected the body from its costs. Stillness also became social. Groups rested together. Fires encouraged gathering in one place. Light faded. Movement stopped. The body recognized this rhythm. Day meant travel. Night meant recovery. Upright posture faded into rest. Even today, prolonged standing feels unnatural. The body signals discomfort. Weight shifts. Muscles tire. These signals are not failures. They are reminders. Walking upright was never meant to eliminate other postures. It was meant to connect them. Movement made rest meaningful. Rest made movement possible. In the next part, we'll explore how upright walking reshaped the human nervous system, and how balance, prediction, and attention evolved together with posture. For now, the body remembers this rhythm. Move, pause, settle. Walking upright placed new demands on the nervous system. Balance could no longer rely on wide support. Each step required anticipation. The body had to predict where weight would land next, before the foot touched the ground, before instability occurred. This prediction became central. The nervous system began integrating information continuously, from the eyes, from the inner ear, from muscles and joints. These signals combined to create a sense of orientation, not consciously, automatically. Upright walking demanded this integration every moment. A small miscalculation could lead to a fall, so prediction became fast and reliable. The brain learned to simulate movement ahead of time, not as a thought, as a bodily expectation. You experience this when stepping onto uneven ground. The body adjusts before you think. This anticipatory control reduced effort. Instead of reacting to imbalance, the body prevented it. This shift shaped cognition. Planning became embodied. Routes were evaluated visually. Distances estimated. Terrain read. The eyes began working closely with the legs. Vision guided movement. This coordination allowed attention to remain outward, while the body managed balance internally. Walking upright also sharpened spatial awareness. The nervous system tracked body position in three-dimensional space. This awareness extended beyond walking. It supported tool use, throwing, building. Precision improved, but prediction required trust. The nervous system had to assume continuity, that the ground would remain stable, that steps would follow rhythm. When this trust is broken, attention snaps back. Slippery surfaces, uneven stairs. Suddenly, walking becomes conscious. The nervous system increases monitoring. This shift costs energy. It also creates tension. The ease of walking relies on predictability. This is why familiar paths feel effortless. They reduce uncertainty. The nervous system has already mapped them. Upright walking also influenced emotional regulation. Movement stabilized internal rhythms. Steady walking regulated breathing. Breathing regulated heart rate. This created calm. You can feel this when walking without hurry. Thoughts slow. Attention broadens. This effect is not accidental. The nervous system evolved to associate sustained upright movement with safety. Movement without urgency signaled stability. This association remains. When movement stops abruptly, alertness can rise. Stillness without context can feel uncertain. This is why gentle movement often precedes rest. The body needs transition. Walking upright taught the nervous system how to manage that transition. In the next part, we'll explore how upright walking influenced human social life and cooperation. For now, balance continues quietly, guided by prediction. Walking upright placed new demands on the nervous system. Balance could no longer rely on wide support. Each step required anticipation. The body had to predict where weight would land next, before the foot touched the ground, before instability occurred. This prediction became central. The nervous system began integrating information continuously, from the eyes, from the inner ear, from muscles and joints. These signals combined to create a sense of orientation, not consciously, automatically. Upright walking demanded this integration every moment. A small miscalculation could lead to a fall, so prediction became fast and reliable. The brain learned to simulate movement ahead of time, not as a thought, as a bodily expectation. You experience this when stepping onto uneven ground. The body adjusts before you think. This anticipatory control reduced effort. Instead of reacting to imbalance, the body prevented it. This shift shaped cognition. Planning became embodied. Routes were evaluated visually. Distances estimated. Terrain read. The eyes began working closely with the legs. Vision guided movement. This coordination allowed attention to remain outward, while the body managed balance internally. Walking upright also sharpened spatial awareness. The nervous system tracked body position in three-dimensional space. This awareness extended beyond walking. It supported tool use, throwing, building. Precision improved, but prediction required trust. The nervous system had to assume continuity, that the ground would remain stable, that steps would follow rhythm. When this trust is broken, attention snaps back. Slippery surfaces, uneven stairs. Suddenly, walking becomes conscious. The nervous system increases monitoring. This shift costs energy. It also creates tension. The ease of walking relies on predictability. This is why familiar paths feel effortless. They reduce uncertainty. The nervous system has already mapped them. Upright walking also influenced emotional regulation. Movement stabilized internal rhythms. Steady walking regulated breathing. Breathing regulated heart rate. This created calm. You can feel this when walking without hurry. Thoughts slow. Attention broadens. This effect is not accidental. The nervous system evolved to associate sustained upright movement with safety. Movement without urgency signaled stability. This association remains. When movement stops abruptly, alertness can rise. Stillness without context can feel uncertain. This is why gentle movement often precedes rest. The body needs transition. Walking upright taught the nervous system how to manage that transition. In the next part, we'll explore how upright walking influenced human social life and cooperation. For now, balance continues quietly, guided by prediction. Once upright walking became reliable, humans did something subtle but powerful. They began moving together. Walking in groups altered behavior. Speed had to be negotiated. Direction had to be shared. Attention expanded beyond the self. Moving together required awareness of others' pace and position. This fostered cooperation. When walking upright, the face is visible. Eyes face forward. Expressions can be read. This supported nonverbal communication. A glance could signal direction. A pause could indicate caution. Walking together created rhythm. Footsteps synchronized. Breathing aligned. This synchronization strengthened group cohesion. The nervous system responded to shared movement. Stress reduced. Alertness balanced. These effects remain. You can feel them when walking with someone at a comfortable pace. Conversation flows differently. Silence feels less heavy. Movement carries social connection. Upright walking also influenced leadership. Those at the front could scan ahead. Those behind could watch the group. Roles emerged naturally. Direction was shared visually. Gesture and posture communicated intent. This reduced reliance on sound. Silence became functional. Group walking also supported migration. Long journeys became possible. Knowledge of routes was passed down. Landmarks were remembered visually. Walking upright allowed stories to attach to places. Memory became spatial. This spatial memory supported culture. Paths became meaningful. Trails formed. Movement linked generations. Children learned by walking alongside adults. Imitation happened naturally. Pace was adjusted. Walking became teaching. Even today, walking side by side feels different from sitting face to face. It reduces confrontation. It encourages shared focus. This reflects deep evolutionary patterns. Upright walking also influenced conflict. Groups could move as coordinated units. Positioning mattered. Awareness expanded beyond individual threat. Cooperation improved survival. Walking upright did not isolate humans. It connected them. In the next part, we'll explore how upright walking influenced human identity and self-perception. For now, movement continues as a shared experience. As upright walking became familiar, something quiet changed in human awareness. The body began to feel different. When movement happens on four limbs, attention is spread. Contact with the ground is constant. Support feels distributed. Upright walking concentrated effort. The body rose above the ground. Balance became a continuous concern. This shift brought the body into awareness, not as an object, but as a presence. Standing upright made posture meaningful. The position of the spine, the angle of the head, the distribution of weight all mattered. Small changes affected stability. The nervous system began monitoring the body more closely. This monitoring did not remain mechanical. It influenced perception. Standing upright changed how humans felt themselves in space. Height increased. Perspective widened. The world appeared more distant. This distance allowed reflection. The body became a reference point. This awareness shaped identity. Humans began distinguishing between self and environment more clearly. Movement created a boundary. This boundary supported introspection. Walking upright also made fatigue noticeable. Effort accumulated in specific places. Legs tired, feet ached. The back felt strain. These sensations informed behavior. Rest became intentional. Pacing became deliberate. Awareness of limitation fostered planning. You could not walk endlessly without consequence. The body reminded you. This awareness supported empathy. Recognizing one's own fatigue made others' effort understandable. Social care deepened. Upright posture also changed expression. The chest faced forward. Arms moved freely. Gesture became expressive. Emotion could be communicated through stance. Confidence, caution, fatigue. These signals were readable, even without words. Walking upright thus shaped communication beyond speech. The body itself spoke. As night approached, upright posture relaxed. The body folded back toward the ground. Sitting, lying down. These transitions were felt deeply. The nervous system recognized them as safe. The contrast between upright effort and horizontal rest became meaningful. This rhythm structured the day. Movement and stillness gained significance. In the final part, we'll bring this long story together. From tentative standing to the way you move through the world today. For now, the body continues to feel itself. Human walking never reached a final form. It reached a workable one. The ability to stand upright did not arrive fully formed. It emerged through small adjustments, repeated endlessly across generations. Each change solved one problem and introduced another. Balance improved. Efficiency increased. Hands were freed. At the same time, new pressures appeared. Strain on the spine. Stress in the joints. The constant need for coordination. These trade-offs remain part of your body today. When you walk, you are not using a perfected design. You are using a negotiated one. A body shaped to move forward slowly and steadily. A body that expects variation. A body that relies on rhythm. Upright walking did more than change how humans moved. It changed how they lived. It allowed distance to matter. It allowed sharing to become practical. It allowed cooperation to extend beyond immediate reach. It shaped attention, planning, and social connection. The nervous system adapted alongside bones and muscles. Balance became predictive. Movement became calming. Rest became necessary. These patterns still guide experience. When walking feels grounding, that is not accidental. When standing too long feels uncomfortable, that is not failure. The body remembers why it learned to move this way. At the end of the day, upright posture softens. The spine curves. The legs release. The ground draws closer again. This return is part of the design. Walking upright was never meant to be permanent effort. It was meant to connect moments of movement with moments of rest. Your body continues that rhythm quietly, step by step, pause by pause, still learning.